The movie projector was invented over a century ago, and the concept is the same today. Film revolves in front of a light which projects an image onto a screen. But the latest technological advancements make the projector a real showpiece. Its film is 10 times larger than normal, and the projector magnifies it 400 times, as it moves it in a sideways rolling loop, rather than the traditional vertical feed. And instead of the usual sprockets, registration pins retract as the film loads, and then reach out to steady it as it rolls. A vacuum sucks the film to the aperture lens. This is how they keep the gigantic image perfectly steady. To make an IMAX projector, 2 prisms are bolted together and mounted on a part called the lower illumination module. The prisms and the mirror will reflect the projector's light to a similar part called the upper illumination module, which will relay the light to the lens. It's a fly's eye lens, a collection of mini lenses on one glass. Each will focus to a single point, ensuring an even distribution of light. A technician screws 2 fly's eye lenses together and then places them in a fixture to align the 2 halves. He switches on a light and places an alignment guide over the lenses. There are red and green filters on this guide, and he brings them into focus. He adjusts them until the red and green lines merge. It means the 2 lenses are now aligned. Next, the upper illumination model is installed in the projector frame. And then they flip it. The protective cap is removed from the back. Then it's attached to the lower illumination module, which we saw assembled earlier. Here, the rotor support and motor are bolted together. This large wheel is the rotor. It's the heart of the projector. It drives the film forward in that distinctive wave-like action. This piece, called a stator, will act as a guide for the film. The aperture block is fitted to the front of the frame. It's lowered onto the base using a crane. Spacer bars are screwed in. And the second projector assembly is installed. These 2 assemblies will enable the system to run 3-dimensional movies. Now it's time to position the main lens at the front of the projector. The lens caps are removed and it's ready to roll. The film wave happens 24 times a second. We've slowed down this footage so you can see it all happen. The film of a test chart ripples in front of the aperture, and then vacuums pull it down for a 24th of a second. This eliminates any shakiness in the projected image. Now we're showing it in real time. So you get the picture. There is also nothing ordinary about the lamps the IMAX projector uses. They're very powerful, but they use the light very efficiently. And now, it's time to enjoy the show. Roller chains really keep things moving, and without them, a lot of important equipment would be powerless. Chains transfer energy in industrial and agricultural machinery, and without one, your push bike would be going nowhere fast. To make a roller chain, a punch press pulls steel from a giant spool. Using 500 tons of force, it cuts shapes out of the steel. These shapes are the link plates that will join all the parts of the roller chain. The plates travel on a series of conveyors. An arm positions them as they head towards the next punch press that makes 2 holes in each link plate. Then they're poured onto a tray and spread evenly across it. A vibratory mechanism shuffles them into a blazing furnace. This heat treatment toughens the steel. Then they cool down slowly in a tank of oil. After that, they go for a tumble in the washer to get rid of the oily residue. Meanwhile, another machine uncoils some steel to make bushings or sleeves for the chain pins. The blade slices the material to the correct length. Then mechanical arms fold the steel around a mandrel. Here's the action in slow motion. In real time, it all happens faster than you can blink an eye. The bushings fall into a bin. And now they're ready to be heat treated. A rail car takes the bushings into a furnace. This may look destructive, but the bushings will come out stronger. Now it's time to make the pin that will hold everything together. This machine shoves a steel rod into a jig and a saw cuts it to size, which varies depending on the chain it will be used for. A mechanical arm then picks up the pin and transports it to rotating heads, which machine down the ends. The pins then travel across a grinding wheel, which reduces them to a specific diameter. Next, they go through a wash cycle. A special mix of lubricant and solvents rinses away the residue from the grinding. These are the pins before and after grinding. Now it's time to put the pieces together. This is a breakdown of what happens at a blurring pace on the assembly line. The link plates and bushings go into an assembly device. A ram presses them together. They're removed and 2 more link plates are placed in the device. Rollers are positioned on top of them, and the bushings and link plate assembly are slid into place. It's all press-fitted together. And now they have links for the roller chain. The next step is to fit the roller links together. They're clamped into a fixture, and pins are slid in. A hydraulic ram presses the pins to the base of the assembly. Then the pins are connected with another link plate and pressed in place. This is repeated as the roller chain is lengthened. It can also be widened to enable it to handle more horsepower. To do this, single strands of roller chain are stacked. Longer pins are used to hold all the layers together. Again, a fixture holds it in place while the ram does its work. This produces heavy-duty roller chain. The one shown here can handle 400 horsepower. Finally, the roller chain is lowered into a vat of hot grease to lubricate the joints. And that's the chain of events that leads to the roller chain.